Good afternoon, YouTubers. Today here I'm going to be discussing my new Steam engine, and this is truly Steam. I mean, this is the basic for this design is that I want to use Steam, real Steam. So there's a lot of improvement versus my first design in where I was forced to use air because the valve here was too thin that Steam will destroy the valve, but this is different. And basically, what I'm doing right now here is that you can see that there's the boring for here is the valve, and for the piston, I'm going to be using 3/4 PVC. That's the diameter of the PVC that I will be using, about 3/4. And that, as you might know, the PVC has some thickness. So eventually, the inner diameter of that PVC is about, if I remember that right, it's about 20 millimeters or so. And so I will reinforce the diameter of the valve with a PVC. That's the idea, to reinforce this section. And there's the same size on both the piston, the power piston, and the valve. But the valve is kind of a different. I mean, this valve has been beefed up a lot. So I would say steam might not damage the valve. So the main point here is, let's do a quick simulation here of how this will work. So let's see. Actually, let's run it here. Motion. Let's do a motion study, and let's see where am I right now. It's gonna be for that one 0. So the last step on that one, on that simulation, will be let's say 100 here. So it will be about 360. So there we go. And now let's say I want to so you can circle, and let's run. There we go. It's turning counterclockwise because basically air or steam, and that's for sure it's going to be steam, it's going to enter through here, and this is the one that will connect to the back of this size. I haven't done the bore here, I should, and to finish this. So right there is going to be where I will be putting another connector, like from here to here, and this is the escaping, uh, or your steam will come out through this uh, hole here. So I haven't finished yet the boring and the thread that I need here on this part here, but it's just to give you an idea of how this looks like and how this steam engine will perform. There's many things that I'm trying to implement here. Let's move the speed, very fast piece. It worked pretty well, since I'm not using any contact surfaces. It worked perfect. Now let me go more slowly on this, very slow. This part here, this is gonna come from a fan, uh, the from a motor, from a fan motor. I will use the internal part of the fan motor that is heavy enough. I can have a lot of friction here and still should work, because basically this piston will have a groove for a seal, a rubber, kind of an O-ring seal against the PVC. So I definitely believe that this will work better. Now, in terms of timing, there's a whole new story here that I have to say that is totally different from regular steam engine. Uh, I'm not using actually eccentric. I'm not using eccentric. I'm using exactly what I have here on the power piston on the crank. It's the same crank that I have right here on the valve. So that's why you have these three holes here, and there's going to be power pretty much in the whole direction of the power piston, and it's going to be opening, dropping down the piston, so steam or air will escape right through this one. So the story is this: to watch this closely, let's do this. Let's change this to frame so that it's easy to understand what's going on. You see, this is the valve. The valve has a smaller diameter in one point in time, and that will create the connection between the input of steam and this is gonna be a hose that's gonna connect right through this here, through the back, so that so now let's do this way. Instead of having that simulated, let's move it myself so you can understand better what's going on here. But I still want that you see as much as you can and how this is turning counterclockwise. So let's escape from here and let's start to move this very slowly. Like for example, right there, you see at that step when the piston is pretty much right to the bottom. You see, now it start to go up. Now there, it move up. The piston right here start to go this direction. Steam will go right through here, and this part here is closed. So but steam, now you have this and this open, meaning that steam will go right here and will escape through here. Eventually there's a hose connection that's going to connect at the back of this piston and will push it up. So as I turn this counterclockwise, you can see now that the opening is even better for steam getting in and eventually getting into the power piston. So as I keep going up, moving, I still have a lot of steam getting into that engine or the power piston until I got to the top. When I got to the top, then as you can see at the top right there, pretty much there's no steam getting in because it's closed by this part. Remember, this gap that you see here is going to be covered by the PVC, by the thickness of the 3/4 PVC pipe that I'm going to be using to ensure that this can definitely use steam without problem. Now, what's happening now is that you can see that the opening for steam to escape is pretty much is already open. So meaning that whatever steam is trapped here within the piston will come out through here, through a hose, and eventually through here. This is closed, so this will come out through here, eventually through this hole out. So that's how it works. So again, I'm not using eccentric. I'm using the regular cranks for the piston. It's the same one that I'm using on the valve. However, they are 90 degrees apart. So in other words, this crank is 90-degree apart with respect to this one. That's all. Now, if I keep turning this counterclockwise, as you can see, let me see what's I'm a little confused here. Let me see. It's this way. Sorry for that. I said there's something weird. No, it's counterclockwise. That's why. Now, as you can see, I keep rotating this, and now pretty much the the opening of for the piston going from here to here is already still open, but and so the escaping of the gap of whatever is trapped within the piston, so there's no stopping until you get right to the bottom. When you get to the bottom, then the the cycle start again. You open the steam, and the steam will get in through here, eventually back to the back of the piston and push it in all the way to the top again, and thus the cycle repeat itself many times. So I mean, my first design, I always concerned with the thickness of this valve. This valve is quite thick, so I don't think steam, I mean, I'm not planning to use very hot steam. I think at the most about would be 150 degrees C. So a little below to the 200 mark for when the PLA start to get weak. So I will say keep it as between 125 and 150. That will guarantee between 10 20 psi of pressure, good enough that this engine will definitely work. I don't require too much force on this engine, too much pressure to work. So that's the main point. Remember this part here, this shaft and the and the flywheel are part of a fan. You know, the motor, the rotor for the fan. So I will cut it to size and glue the cranks, and you know that's how it should go. Uh, Printing. Before talking about printing, let me go back again um, to this. So you can see there's the chap and there's a gap here. That gap is because I'm gonna be putting there ball bearing. So this flywheel will be in ball bearings. That will definitely ease the any friction in both sides. The crank is identical in terms of length and size on both sides, and the length of the push rod as well. And so let's see anything else that I want to show you here. I think that's pretty much it. The important thing, this looks like a piece, but this will be cut right here. Eventually at the printing time, I'm gonna cut this part. So it's gonna be two sections here. This section, the house, the power piston and the valve will be printed probably this side down so that the internal of the piston and the valve are clean, so you don't need PLA support during printing, and that's very important because otherwise you will have to take all that material out and sand the boring holes, and that's not good. So probably this will be printed that way. Now this part here is belong to two parts. These are the pillow blocks. The pillow blocks, these ones are the pillow blocks, and they are identical as well, both sides, and they will be printed as well, in a separate section. And I probably print them, this size down. So again, try to maintain as clean as possible the boring part, and so the pillow, I mean, this base here will be printed as well, in a different shot. So basically, it's about 4 or 5 type of printing that you have to be careful how you print this, so that avoid having problem with whatever boring you have done on the system. Again, one thing, I'm not sure whether will be the final design for this. For the holes, the input, because this need to be probably make it bigger for the probably for a quarter of an inch hose or hose connector that I will be using here and here and here. So this hasn't I haven't complete this design yet of what I'm gonna be using, and besides also have to do a boring here. Like for example, I have to finish this part here, and it's like I need to do a boring here somewhere. So it's like, let's see if I get the center. Let's see if I can get the center right. Let's do, let's see, that would be, let me see, that would be, to get that right, that should be about, uh, let's say 56, 0 point, I will say 0.56 inches, and so it's 14.224 millimeters. So let's say finish, and so this is a story. So that's where is in steam will go in or out. So let's do boring here, and let's see. hmm with 10 millimeters it will do, I think. Let me see. We'll see it. We'll take a look in a second. Yeah. Now let's move these. Perfect. Yeah. Now, um, that might require to be a little bit thicker as I see it. But because 10 millimeter is not enough probably to get good grip of a connector that you want installed there. So, but I mean that's so you might have to do something here to ensure that you got a good grip of that. Like I put an extra piece here, but I hate that because probably this is gonna be the bottom part when I start to print it. So adding anything here that bothers the printing process, that's not good. So you want this one of the surface as flat as possible, like this one. You want this to be flat, not nothing bothering the printing process. So in essence, what I'm doing here is like go here and when you go here, let's see, do a thread and let's use Acme. Probably I'm using zero point 0.5. Let's use 5/8, and so that will do. So that's oh sorry. Let me go back here for 1 second. Oops. Let me go back and so let's model it, and that's basically it. That's where you will install your host connector for steam getting in out from this hole up to there. So that's the main point to get this done. That will do. I guess that's how this will go. Let's look more into it. Is here are all the part like the body, the pillow block, one of the pillow block, the second pillow block. They are identical. The shaft and flywheel come from the motor, and for the rotor or the fan. Crank, one crank, the second crank. They are identical. I'm not using eccentric here. The push rod and the pin that I'm gonna be using. The other push rod, the other pin. The steam valve, as you can see, is kind of a different. The distance here from here to here is about 40 millimeters, which is about half of the distance for the crank, which is 20 millimeters, and the piston. The piston, I haven't yet designed the groove for the seals. That's gonna be done later. But I'm gonna print the small pieces just for ensuring that I got a good seal without too much friction between the power piston and the internal part of the PVC, internal diameter. So I think that will do. Let's do here. Let's do animate the whole thing, and let's take a look through here. So that's what I want to show you. That this looks pretty much. This looks good. It's about let's see. It's about 290 millimeters. The distance there is about 300 millimeters, meaning about 30 centimeter, about 12 inches. Then the length is about 12 inches, and this part here is about 152, meaning about 15 centimeter, meaning about six inches. So it's about 6 inches, 12 by 6. That's the base, 12 by 6. Basically, because I want to install this on a 2 by 6 piece of wood that is very strong and sturdy. So it will look good, and that's the main point. Again, this design does not use an eccentric, so that will be something to talk about. This timing is power all the way up, and that's kind of different. So not sure how this will work eventually, but I mean here in paper, in design, it looked good. You know, take a one more look to that now that you understand what I'm doing. It's like for example, let's go visual style. Let's go. Let's see wireframe, and now you have a better idea of what's going on. Like for example, right now the piston is right at the bottom, and as I turn this counterclockwise, let's turn this way so you can see me turning counterclockwise. Now you can see that this is open and this is open, so steam is coming out from, from the inside of the piston out. It's coming this way, in and out. As I keep turning down, then you see this is closed, it's getting closed, but now this is getting open. So now is where steam is gonna get in, and I will have full steam getting into through the valve, out to the middle, into here, pushing the piston up, 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 until, there we go, until the cycle chain. And now the piston is coming down, and you have this opening. So the steam here is going to be pushed out through the middle here and coming out through this side until eventually the cycle repeats itself. And that's more or less the design that I'm working on. Let's see. Let me animate that. So there we go. The travel here, the stroke is about 40 millimeters. That's the full stroke because the crank is about 20 millimeters. And and it's turning perfect in the right direction. When I finished doing this work, it was turning the wrong direction. So I had to do something that is called here a spill joint and do some changes on one of the joint that I have put together so that it's turned counterclockwise on this design. Because the other way is that then steam will have to go through here, and this will be an exit. So you can change either way, but this design is better to have steam on this side because this the valve will have O-ring as well to ensure that we don't waste too much steam through the gaps between the valve and the internal side of the internal diameter of the PVC. Well, folks, nothing else to say. I'm working on this, still doing a few things here and there. I'm still need to figure it out this diameter, but as you can see, this diameter are huge. If I'm planning to use those MPT type of fittings, they will be huge here. So probably the one in the middle will be in the top. That's that one thing that I'm gonna be working on. Probably gonna put this guy here at the top, and this one and these two will stay the way they are. And the only weak part that I see here definitely will be the valve again, but this is thick. I mean, we are using very thick. Again, about I would say it's about 12 to 15 millimeters if I remember the internal part of the valve. The external, the other part of the valve here is about 20 millimeters. So it's just the internal part here that might be too thin, and steam might create some damage. But I'm planning to use steam below 150. See, that will provide enough pressure. It's going to be wet steam. That's the what I'm going to be using. Wet steam, nothing like superheated steam. That will create a problem. I don't want that. So wet steam will do, and will protect the part as well, so without too much damage. Well, folks, that's it. Have a great day. And again, this was done in Fusion 360, and we'll see. Let's get this back to visual style. That will do. And this is basically how it looks like at this point. I'm going to try to do some math modeling as well for the inertia, taking in consideration the flywheel inertia and all that, and see what would be a good behavior of this steam engine before I get everything printed in case I have to do some changes. This flywheel It's about 200, 300 grams. I haven't, it's kind of heavy. So that's what I think that it might work okay with the seals because I'm gonna have some friction, heavy amount of friction at least in the power piston. I plan to use the from 2 to 3 O-rings on the power piston for a good seal. So that's it. That's it, folks. Have a great day. Bye.